Hello, my name is Elaine Roddy, and I'm a vegetable crop specialist with the Ministry of Agriculture, Food and Rural Affairs in Ridgetown. This is the sweet corn, bean, and pea integrated pest management workshop. And in this module of the workshop, I'm going to be specifically covering the Lepidoptera pests of these crops. So Lepidoptera pests are the larvae of moths, and there are several different ones that we deal with, mainly in sweet corn, somewhat in beans, and much less common in peas. So as early season pests, we deal with the cutworm and the armyworm, and they impact all three crops, more commonly seen in the sweet corn and the beans than in the peas, but they can impact peas. As a main season pest, we will be looking at corn earworm, corn borer, and western bean cutworm. And the corn borer is certainly a significant pest of beans as well as corn. And the western bean cutworm, we haven't seen a lot of problems with western bean cutworm in snap beans, but it is something that they can feed on. And as far as a late season pests go, we'll be looking at the fall armyworm. The most common of the pests will be the corn earworm, the European corn borer, and the western bean cutworm. Those are the ones that we tend to see most often. So as far as cutworm go, there are various different species that we see in Ontario. Most of them do not overwinter here, so they are blown up in the early spring in spring storms. And at that time, they will seek out, the female moths will seek out any green cover they can find to lay their eggs. So they're commonly found on winter annuals, such as chickweed. And that's where they initially lay their eggs and hatch. And then when the commercial crop is planted, those larvae will move into the commercial crop. Some of the species that we tend to see in Ontario are the greasy cutworm, the black cutworm, the dark-sided cutworm, and the sandy hill cutworm. And they tend to be a pest anytime from mid-May to early July. They do have more than one generation, but it is that first generation that is more likely to be a problem in commercial crops. So as far as identification goes, the moths are fairly nondescript and they're nocturnal, so we don't tend to see them active in the crop. And then the larvae themselves can range in color and shape and size, but the damage they cause is quite similar regardless of the species. And they will literally cut the top of those plants off. So you can see by these bean hypocotyl here that a cutworm has been down that line of the row and it has, at the soil surface, cut off the top of those plants and fed on that portion of the plant, leaving the roots behind. And so in this case, the bean field literally disappeared overnight. There was a giant swath of the field that had been there on Friday, and on Monday, it was completely gone. There was nothing left. And when we dug around, those cutworms had taken everything off the top and left those hypocotyls behind. So the cutworm are actively feeding on the crop for the later stages of their lives. So when their head capsules are very small, they're not going to be cutting plants. They're just going to be doing a little bit of feeding on the leaves and not causing a lot of damage. And like I said earlier, at that stage, they tend to be on non-crop plants in the winter annuals. Once they reach the fourth instar, then they can start cutting young corn plants, and they will continue to feed quite voraciously over a number of nights until they reach about 1.5 inches in length, or that 5/32 of an inch head capsule width. At that time, they will stop feeding and they will pupate and move on to the next generation. So when you're finding very large larvae in the field, a spray might not be necessary because they're done feeding at that point. However, with the smaller head capsules and the younger instars, that threshold is about 10% feeding damage as a control. So the common armyworm is also active in late spring to early summer. And it is a sporadic pest. There are years where we will see a lot of them, and then there's years where we don't really get any reports of them at all. And they tend to move in large numbers, which is one of the reasons why they're called an armyworm, because you have massive amounts of them moving through the field. And so corn is one of their preferred hosts, but they will eat a number of different crops. Once again, it's a fairly nondescript moth. You can see here that there are 2 small white dots on the moth, but the moths are not what we're scouting for. We're looking for feeding damage, and we're looking for the presence of these larval worms. And they've got the dark band along the side, and then they have the diagonal stripes at the top of each proleg, kind of like the insignia on a uniform, which is why they're called armyworm. So they're another one that will lay eggs early in the spring, being driven up here in the trade winds of spring storms. They'll feed on whatever they can, and then as populations build, they'll start to move into corn crops. And they can cause massive amounts of very obvious feeding damage and large amounts of these frass. So you can see the number of different armyworm on this plant, and they are taking everything off that leaf except for the midrib, and large amounts of frass behind. You'll usually notice the frass before you notice anything else. When you're considering the threshold at the seedling stage, obviously they're going to be more susceptible to injury. So we're looking at a 10% threshold. 10% of the plants with damage or larvae is our threshold at the seedling stages. And once the plants reach mid-whorl, so about V6 to V8 onwards, then we're looking at about a 50% feeding injury. And when you're scouting, check for the presence of parasites, because sometimes there are parasites that are living off of the body, and they will do a very good job of causing it to cease feeding and control it naturally. So if you're finding a lot of parasites and the threshold is, and the numbers are just around threshold, you might want to hold off spraying. So the next pest that I'm going to talk about is the corn earworm. And this is probably the most problematic pest that we deal with in sweet corn. It is something that we see every year and can cause massive amounts of damage if it's left uncontrolled and there are high populations. So the plant is most susceptible during the silking stages. When we look at the larvae themselves, they're quite easy to identify because they have this double pinstripe running along their back, along their dorsal side. So when you see that pinstripe, that is a clear marking of the corn earworm. The eggs themselves are very small. They're laid singly and they're perfectly spherical. And as you can see, they're slightly ribbed. The diameter of that egg there is about the same diameter as the silk on which it has been laid. So for that reason, they are very hard to scout for. You can see them with your naked eye, but it's something that is very difficult to see and very time consuming as far as scouting would go. So we're not able to scout for the eggs. The eggs are laid on the silk, and upon hatching, they will eat down the silk and into the protective cover of the husk, and they will spend the rest of their lives protected by the husk. So when you're looking at a window of control for this pest, it's literally 2 or 3 inches, the amount of time it takes for that egg to hatch and that larvae to reach the protective cover of the husk, because once it's inside the husk, insecticides are not going to be able to reach it, and you're not going to be able to control it. So having coverage on the silks and having the timing of the spray timed so that the green silks are covered as they're actively growing, because you need to remember that the silks are growing 1 or 2 inches a day. So that coverage needs to be there in order to control this pest before it enters the ear. These are the moths, and they've got a wavy band along the bottom, and then these 2 dark brown spots. And then interestingly, they also have very bright green eyes. So if you're trapping for them, that is something that you'll notice on the live ones, is these bright green eyes, and they darken to about an olive green if they die while they're in the trap. So here's a picture of two of the corn earworm. And you can see there's quite a big difference in the coloration. So identifying insects based on color is never a good idea. You need to look at other characteristic features. So in this case, it's that double fine line. And this is the type of damage that it is doing in the tip of the ear. It is eating all of those cobs, all of those kernels. You rarely ever find more than one earworm in an ear because they are cannibalistic. So the dominant of the newly hatched larvae will eat the other ones, and then it will take the rest of the cob for itself. In this case, I actually moved one of those larvae onto the cob so that I could have the two together for a photograph. And again, this is some more of the damage that it causes. It's very unpleasing to the eye. The presence of corn earworm inside the cob is distasteful and customers don't want it. So from a fresh market standpoint, our threshold and our tolerance is very low because you can't sell corn that has worms in it. And even from a processing standpoint, even though those worms can be sorted by the automatic color sorters, it can slow down the plant processes. And there's always that risk that some will get through and be a contaminant in the consumer product at the end of the processing stage. So we really can't have these insects in our corn. Not to mention the yield loss that it also causes by eating the cob itself, the kernels. But here's a bunch of different larvae and different stages and amounts of damage that they've caused. So we can trap for this pest. We're not able to scout for it easily because it is protected by the husk and we can't see it until it's too late. So we are able to trap for it, and there are two different types of traps that are commonly used. The one in the front of the picture here in the foreground is called a heart stack trap, and it is a rigid wire mesh. It is more effective. It will routinely catch about 3 times more moths than the other type of trap will. Unfortunately, they're not available for purchase. You need to assemble and manufacture them yourself, which is a bit fiddly. It's doable. And if anyone is interested in doing it, I do have the instructions or blueprints for manufacturing them, but it's a bit fiddly and it takes time and materials, and they're fairly expensive when all is said and done. They're also a pain to store. They take up a lot of room because they are rigid. They cannot collapse and just shove them into a storage cabinet. The one in the back is called a heart stack trap, and that is more commonly used, and they are available for purchase commercially. They're a lot easier to store, and they have a similar concept as far as the design goes. For some reason, they're just not quite as effective. So for the trap, how it works is you have a pheromone, which it mimics the female sex hormones, and they attract the male moths out of their habitat and into the trap. And so the pheromone is suspended at the bottom of the trap, usually on a string with a paper clip, or in this case, there's a rigid metal bar in the front that you paper clip the pheromone to. And when the moths, which tend to hang out in the grassy areas beside the field, when the moths smell that female sex hormone, they fly into the trap. When they realize there's not a female there, their natural instinct is to fly straight up. And that's where we've got this kind of bucket-like portion on the top of the trap, which is detachable. So you can, and there's a cone inside it. If you can just barely see, there's the bucket shape, and then there's the top cone of the triangular shape. They'll fly out of that cone straight up. And then when they can't get out straight up, they can't fly down. That's not their natural instinct to fly down. So they're trapped in that bucket section. And then you can come along as a scout, remove the top of that bucket, and count the number of moths that are in there. Some of them will still be alive, so you have to count really quickly as they fly away. Many of them will have died over the days or weeks since you were last there. And numbers can range. There could be 1 or 2 in the trap, and there have been times, especially in the later part of the season, where we can have hundreds of moths move into those traps, really depending on the weather patterns, because they're another one that overwinters in the southern states. In the southern states, they're a pest of cotton. They're known as the cotton bollworm. Also cornfields in Texas, Louisiana, that's where they overwinter, and then they're pushed north in the summer storms. So we really tend to see populations increase in Ontario when the hurricane season starts, as the tail end of those hurricane storms come into the Great Lakes Basin. The air hits, the warmer air from the south hits the cooler air of the Great Lakes, causing either rain or dry deposition, and those moths land into the fields of southern Ontario, and that's where we tend to see the populations spike. So we can monitor all of that with the traps. The important thing is that the traps have to be beside freshly silken corn, so you need to move them regularly so they're always near an attractive crop, because those moths are only going to lay on fresh silks. You need to replace those lures every second week, and you really want to have them in the field by early July. Even though high populations tend to occur in the later summer months, we can still have populations arriving in Ontario early, and so it's not uncommon for us to have very pinpoint sporadic episodes of corn earworm early in July. And whenever you're working with pheromones, it is really important to avoid cross-contamination. So if you are doing a number of different types of traps, you need to be wearing gloves or using tweezers when you're handling those pheromones, so that you're not accidentally mixing the scent of a corn earworm pheromone with a corn borer or a western bean cutworm pheromone. And even the oils from your hands can contaminate that pheromone. So you don't want to be handling them with your bare hands. So these are the two different traps in a little more close up, and you can see the cone shape of the inside of the trap and then the bucket, and that's where the moths get suspended until you come in and let them go. For western bean cutworm, we more commonly use a bucket trap. And that's based on just the behavior of the moths. They behave differently. They're more likely to fly down. Once they reach that pheromone, they're going to fly down and get trapped in the bucket portion of this green trap here, as opposed to the corn borer and the corn earworm, where we use these traps for them. Their natural instinct is to fly up. So it is important that you have the right type of trap for the insect that you are trying to monitor. So there is a fairly new website. It's been around for a couple years now, called the Great Lakes and Maritimes Pest Monitoring Network. And this was organized by a number of different partners. And Ontario, our entomologist, Tracy Bowdy, our field crop entomologist, has been a big part of getting this up and running with the collaborative partners. And so through this pest monitoring network, we've got citizen scientists, we've got researchers from all of the different jurisdictions, universities and government, and cooperative extension in the states. And they're all able to go into this network and input their trap counts. And so when you look at it, you can choose which pests you want to look at. So in this case, I've got it on the corn earworm folder, and I can go in at any time during the summer and see what the counts are in the traps that are being reported. And so that's a really good way for me to keep track of what's going on. And especially as we start to get reports in the states to the south of us, that's a good sign that we're going to start seeing problems in Ontario as well. It doesn't replace trapping on your own farm, because the populations can be very localized based on weather patterns. So you could have rainfall on one concession and not rainfall on the other concession. And that's where we're seeing those corn earworms drop down, is in the thunderstorms and the rain showers. So our populations will really depend from field to field. So the best way to keep track of them is to have traps in your own fields if you're able to do that. But if you aren't able to do that, then this monitoring network definitely gives you a regional picture of what's going on. And so you can see here from the 2021 catches that we did have a small presence of earworm in early June. We had small deposits, and numbers stayed very low throughout the summer, which is good, but low numbers when we've got zero tolerance are still important to be aware of, because those low numbers in your field could mean the loss of a customer if you've got outbreaks in that field. And then through the summer months, and as we get into the hurricane season, you really see those numbers increase with very high numbers in the middle of September, at which point most of the sweet corn is no longer susceptible. But if you've got freshly silken corn at that point, it definitely needs to be protected. And this is just looking on over several different years, really similar type of story to last year. Can arrive early, numbers stay low, and then we get these peaks based on weather patterns. So our spray schedule can be based on trap counts and also temperature. And so when we're looking at controlling those silks, because they grow very rapidly, you don't want to have to be in there every day spraying because that's very expensive and it's not the best management use of our pesticides. So by having the traps, we can figure out how regularly we need to be in there. So when populations are low, 1 to 6 moths per trap per week, and the temperatures are below 27 degrees, then you're looking at a 5 to 7 day spray schedule. As the moths increase, the spray schedule decreases. So 5 days and then down to 4 days if we're getting really high numbers. And if the temperatures are high, that's going to reduce the longevity of that insecticide activity. And so then you need to be in there a little more frequently during the green silk period. Once the silks dry down, they're no longer attractive to those moths. But if an infestation happened before that, the larvae are still going to be inside those cobs. You can't get rid of what's already there if you were a little bit late in your spraying. And this is a good example, this trial here. We had extremely high numbers, several hundred moths in the traps at the site near St. Thomas a few years ago. And the silks were already fully in silk, and an insecticide had not been applied at that time. So we were late getting in there with the spray for the number of moths that we had in those trials. So where we left it untreated, we had 100% cobs had been infested, and 56% of those cobs had living larvae. One spray during green silk, we reduced the number of cobs infected and a lot less living larvae. But still, when you look at that second picture there, that's still unmarketable. You still can't sell that. And then the 2 sprays during green silk, we were able to dramatically reduce the amount of cobs infested. So 32% just had a tiny amount of tip feeding, which depending on your market, that still would render them unacceptable for a wholesale sweet corn market. That's still too much damage. And then 6% of the cobs with living larvae. And so that just illustrates that sometimes you do need more than 2 sprays, and also that early spray timing is important too, because we were a little bit late getting in there. So some of that damage had already started to occur before we applied the insecticide, and it's not going to rescue a problem that's already started to occur. So the next one that I want to talk about is the European corn borer, and it's a significant pest of sweet corn and snap beans. And depending on where you live, it can be active through different parts of the summer. As far as insect pests of sweet corn goes, this is less of a concern than it used to be. The widespread adoption of BT field corn has really helped to suppress corn borer populations across this part of North America. So we don't have nearly as high populations as we used to 20 years ago. But it's still something to be aware of because we still see it occasionally and we still make thresholds. And then we also need to be watching for it in the event that we're dealing with some resistance management issues. And that's one thing that I forgot to mention. I'm going to go back up to the corn earworm for a second, because I forgot to mention that corn earworm is resistant to the pyrethroid insecticides. And so during that green silk period, those are not the products of choice. You need to go with either with a group 28 or a group 5 insecticide for corn earworm control. Whereas during the corn borer period of activity, when we don't have green silks, the pyrethroids are still really good choices because they still have activity on corn borer. So the corn borer itself is a fairly nondescript larvae. It's got a black head capsule and it's kind of a transparent, shiny, creamy color. Really not a lot of color to it. The absence of color is a better way to describe it than to actually try and attribute a color to it. These are the moths, and again, they're quite nondescript. The female is larger than the male, and there's a bit of a wavy pattern on the male, but it will not have the dots that the corn earworm had. The eggs are probably the primary way that we want to be able to identify this in the field. And they're flattened and they're shiny and they overlap. So they look a bit like fish scales here. And as you can see on this bottom picture, the head capsules have already started to develop inside those eggs. So when you look at it closely, you can see just a curled up little body with a head capsule in it. And that means that it is about to hatch, which is our ideal timing for control. The earlier, the better for this pest. And so if we can catch them right as they're hatching from their eggs, that's going to provide the best level of control. So scouting for eggs is our primary method of monitoring. Once it hatches, the larvae are very small and they don't have well-developed mandibles at that point. So they will do a little bit of just kind of scratchy feeding on the undersurface of the leaf. So they'll take that tender underleaf material and they can't even make it through the cuticle at that point. So they'll leave the cuticle behind, making these little windows in the leaves. As they continue to develop and they get larger jaws in the second instar, then they'll start to actually make holes in the leaves. And what they will typically do is when the leaf is wrapped up inside the whorl, they will drill a hole straight through that leaf. And when the leaf unwraps, you'll end up with these lines of holes where that drill hole had been made in the curled up leaf. And like the common armyworm, it can leave large amounts of frass behind. And so that sawdusty substance, that is just insect poop. And that's often a sign that insects have been present. Once they leave that initial leaf fading stages, once they hit about the third instar, they are going to bore or tunnel into the stem of the plant, into the stalk. Once they are in the stalk, they are protected and insecticides will no longer control them. So you have a very narrow window of activity during that egg hatch, the window pane feeding, and the pinhole feeding. Those are the stages at which we need to control it, because once it's in the stalk, we're no longer able to. From a biology standpoint, there are two different types of corn borer biologies. There's the bivoltine and the univoltine. And they simply mean 2 generations by 2, so bivoltine, and univoltine is 1 generation. And then that shaded area that runs from about Sarnia through London to Niagara Falls, that's what we call the overlap area. So we have the 2 generational strain and the 1 generational strain. They both live in this area here. And so then we get the basically 3 generations. We get 1 generation for the bivoltine, then we get a generation for the univoltine, and then we get a 2nd generation for the bivoltine. So we have extended pressure in this gray band here compared to the other areas. And of course, we do have a lot of sweet corn growing in that gray band there. So they overwinter as larvae, and you can see they've just, in this diagram here, they're showing they overwinter as larvae, they pupate, the moths come out, they lay eggs. The larvae feed on the corn. In the bivoltine area, that'll be in late June to early July. And then they'll pupate, the moths will come out, and then in August, we'll have another period of activity where the larvae are feeding on the corn again. That's with the bivoltine. With the univoltine, it emerges later and then peaks in July and mid to late July, and then the populations come back down again. So these are the larvae, and where you've had escapes of corn borer, you'll often see broken tassels in the field because they will hollow out the inside of that stem and just move up and down that stem. From a field corn standpoint, that impacts stalk strength and makes it more receptive to diseases as well if you've got the insect feeding in there. From a sweet corn standpoint, what we really don't want to happen is having the larvae move into the cobs, and then we end up with a cob contaminant. One of the ways we can track European corn borer development is through the use of growing degree days, and that is using your local temperature data, your temperature information, and a fairly simple calculation to keep track of what that corn borer development is. Because insects, because they're exothermic, they respond to the temperature in their environment. So trying to predict when they're going to occur on calendar days doesn't really work, because we have warm seasons, we have cold seasons, the temperatures on any given day are going to be different. So by looking at the actual daily temperature, we can then calculate this cumulative growing degree days that give us an idea of the actual amount of biological development that has occurred based on temperature. And so to calculate the growing degree days, we look at the daily maximum temperature, the daily minimum temperature, and we divide that by 2 for the average. And then we subtract the base. And for European corn borer, that base temperature is 10 degrees Celsius. So at temperatures below 10 degrees Celsius, we do not have corn borer activity. So we only count those days where the temperature is above 10 degrees. And that's a cumulative total. So I'll take the growing degree day from April 1st, and I'll add it to the growing degree day from April 2nd, April 3rd, April 4th, and I'll keep on doing the cumulative total through the growing season. And then I can compare that cumulative growing degree day total to establish benchmarks of pest development. In order to do this, I need to make sure all my temperatures are the same. I can't mix between Celsius and Fahrenheit. If I'm using a Celsius growing degree temperature model, that base 10 model, I need to input all metric data. I can get the weather data from Environment Canada and also from OMAFRA, and I'll show you in a moment that we can calculate this on one of the OMAFRA sites. And so then you just choose the information that's closest to your location. Be aware that sometimes there is missing data in that Environment Canada database. Sometimes if a data logger goes down, you can miss a couple days of data. So when I talk about comparing to benchmarks, so we have the growing degree day accumulations for our flights. So that first emergence, the first catch of moths in the univoltine areas happens at 300 growing degree days. Whereas in the bivoltine areas, it happens that much sooner. The first catch in the first generation happens at 150 growing degree days. And then the second generation first catch happens at 700 growing degree days. And then I can also use those growing degree days to mark where the peak catch occurs. And so the peak catch is where peak egg laying is happening. And about a week later is where I'm going to see the most activity in the crop. And so by looking at these numbers, I can use the weather data to say, okay, this crop is at high risk of corn borer activity based on the growing degree days. And I need to get out there, boots on the ground, and scout more often and be prepared to spray if necessary. We don't always need to spray. The populations are low enough now that you can really base it on those growing degree days to know when the flights are active. And then people on the ground, scouts on the ground, to see what is going on in the field. If there are eggs, pinhole feeding, window pane feeding, and then we can use the thresholds. So I'm just going to take a look at the weather dashboard. And I'm going to switch it to, where did it go? I think I must have closed. I think I must have closed that file. So bear with me while I just open up. Oh, there we go. Okay. Just bear with me a moment while I get that website to show you. Okay, so this is the onvegetables.com website, and we have the weather dashboard on there. So once you're on the dashboard, it shows you a map of the cumulative growing degree days, which I was just talking about. That map is at a base 5, which we use for a number of different vegetable crops. So you don't want to use this one for corn borer. But if you select your county, and you have it on 2021, and I'm actually just going to move my date. I'm going to put it on July 1st, July 2nd, 2021. So that's last year. And if I scroll down, I've got several different pest thresholds that will display here. So I've got tarnished plant bug, cabbage maggot, carrot rust fly. And if I keep going down, then I get into the European corn borer. So I can see here that on July 2nd, 2021, in the bivoltine region, I had already passed peak catch. So I'm past peak catch, and this is really the time that I want to be out there monitoring fields for signs of damage in those bivoltine areas of Essex, Lambton, Kent, and then also in that overlap region where that first generation has occurred, Norfolk, Middlesex, Wellington. Those are the areas that are going to be at high risk of corn borer infestation at that time period last year. Whereas if I look at the univoltine regions, they had not yet reached their first peak catch. And so very low risk of corn borer infestation in those areas there. So that's how you can use the On Vegetables dashboard to keep track of what's going on in your area. It doesn't replace scouting, but it allows you to target the time periods where scouting is going to be most important for this pest. So when I'm scouting for the European corn borer, I'm primarily looking for egg masses and the early stages of feeding development. So those overlap fish scale egg masses are about the size of a half of a pencil eraser. They're not terribly big, but they are very easy to see when you're scouting through the fields. They tend to occur on the lower leaf surface, close to that mid rib. So if you're looking there, and as you're walking through taller corn, you can actually look to see the shadows of the corn, and that's often when you'll notice the eggs is when the sun doesn't pass through where the egg is, like it does on a regular leaf. So you're looking for egg masses, you're looking for window pane feeding and that little pinhole feeding. The threshold is 5% damaged plants, eggs, or larvae. Many growers in higher risk periods of time, so when those flights are occurring, they will put on a protective spray as the tassel emerges, just to make sure that they're going to be getting control at that stage. The tolerance level in the marketplace for insect damages, we've already talked about with the corn earworm, tolerance is very low. But given the low populations that we have today compared to a generation ago, that protective spray as the tassel emerges, it can be skipped based on scouting. If you're in there and it's either a low risk time from a biology development standpoint using those growing degree days, or even if the growing degree days are indicating that flight is occurring, if you're in there doing a good job of scouting, looking at least 100 plants across the field, and you're not seeing any sign of egg masses or feeding damage, then that is a spray that could be held off and used as you get closer to silk, when you can target more than one pest with that spray. We can also use traps to monitor for them. We can use the Heliothis trap that I talked about with the corn earworm, or we can use these sticky traps, which are actually milk cartons. They're yellow 1-liter milk cartons, and they don't come sticky, so you have to buy the tangle trap or the sticky stuff. That's the actual trade name for it. I didn't just call it that. You can buy the sticky stuff, and you can coat the inside of the trap using a little, not a paintbrush, but one of those putty knives. You spread it in there, you hang the pheromone, I don't have a picture of it. You hang the pheromone on a paper clip from the top of the trap, and those moths will fly in, realize it's not a female, and then as they go to fly out, they get caught in the sticky material, and you go in there and you check that trap weekly. When you check it, you remove the entire trap and replace it with a fresh trap and a fresh lure. So you're using a new lure every week, compared to the corn earworm, where you're using a new lure every second week. You want to have 3 traps in the field, and you want to have them about 15 meters apart and about 1 meter off the ground. And all of our traps in sweet corn are going to go in the grassy hedgerows, because that's where the moths tend to spend their resting hours, and they're only flying into the cornfield at night. So you can catch them as they're going into and out of the cornfield in their daily migration. And just to complicate things, we do have different strains of pheromones. So we've got the different generational behavior, and then we've got the different strains of pheromone that they respond to. So the E strain, which was also known as the New York strain, the moths, the E strain moths are attracted to corn, and they also feed on other host crops, potatoes, wheat, peppers, snap beans. So that E strain is quite important from a horticultural standpoint. And then the Z strain, which was known as the Iowa strain, they tend to be only attracted to corn. Having said that, they didn't read the manual, so you can sometimes find Iowa populations feeding on horticultural crops. And then in some regions, and we believe this is the case for Ontario, both strains exist. And so when you look at the IPM monitoring website, you'll see that they provide the data for the E strain, the Z strain, and they also have a hybrid strain that they're trying out to see if you can use one pheromone lure to monitor both populations. So all of that information is on the Great Lakes Maritime's IPM monitoring site. And then just to complicate things for the European corn borer, in recent years, this is going back to 2019, this article, in recent years, they have been finding small populations of BT-resistant corn borer in field corn. And so that is something to keep in mind as corn methods change, and hopefully this is just localized populations and it doesn't become widespread, but we need to be keeping track of what's going on in the field crop world with their cryogenics, how well they're controlling their resistance management tools, because what happens in that greater corn population will spill over into the sweet corn management side of things. So at the moment, those BT hybrids really do keep our populations low, low, low. And so the next one that I'm going to talk about is the Western bean cutworm, and it's a newer pest in the landscape, but it's probably been around for 15 or 20 years now, so it's not that new, but compared to the other ones, we still think it's kind of new. It is primary host is field corn. We will see it in sweet corn, and there have been documented feeding in snap beans that is much less common. So it does overwinter in Ontario, first detected in 2008. And we saw increasing populations through 2009 to 2011, and then things did seem to level off a bit, but it is still a major concern in field corn and somewhat less of a concern in sweet corn. The moths themselves are actually kind of pretty compared to many of our sweet corn moths, and they have the spot and the stripe. It's quite characteristic. They overwinter in a soil cell, so as a prepupae, a mature larvae, they will overwinter in a soil cell, and then they will pupate in late May and emerge in July or August, depending on the year. The eggs are laid singly in clusters, so each individual egg is very round. They are a creamy to yellow color, spherical, when they are first hatched, and then as they mature, they turn purple before they hatch. You usually see them on the upper surface of the leaf, on the top 3 to 4 leaves of the canopy, and those females are attracted to pre-tassel corn. Once corn has tasseled, they are no longer going to be laying their eggs in that field, but that's something to keep in mind if Western bean cutworm populations are high, if the trap counts are high and flights are occurring, and the field corn in the area has already tasseled, and there's pre-tassel sweet corn in the area, then that becomes a very attractive crop for these moths to lay their eggs in. So looking at the crops around you and being aware of when peak flight is happening can help you time your scouting activities in the sweet corn. So the larvae can be, you can tell the difference between them and some of the other pests based on these stripes that they have behind the head capsule. So there's the head capsule there, and then they have these 3 round stripes immediately behind the head capsule. The body is smooth, it doesn't have any spines. The European corn borer has hairs or spines on it, and there's no other markings on that one. It is easily confused with the European corn borer. The European corn borer has that black head capsule, and it can be spiny, and it doesn't have those stripes. So when we look at peak flights over a number of different years, so if we look at 2015 to 2021, the peak flight tends to occur anywhere from that 3rd week of July to the 2nd week of August, depending on the year. So that's kind of our hot spot there for keeping track of what's going on that trapping website for when the peak flight occurs, and then looking in our fields, especially based on the development of the field corn in the area as a predictor of risk in sweet corn. If that field corn is no longer attractive to the Western bean cutworm and they're flying, then we definitely want to be out there scouting our sweet corn for the presence of larvae. Peak hatch occurs about a week after peak flight. So those moths are out there laying eggs at peak flight, and then a week later, those larvae are emerging, and that's the time to be looking for feeding damage. So if we want to compare the Western bean cutworm and the corn earworm, the Western bean cutworm has those 3 bands behind the head capsule, and the corn earworm has the double fine line and no markings on the head there. In snap beans, where we have seen damage, they tend to tunnel straight into where the seed in the bean is and leave these tunnel holes inside it. That's much less common, but it is something to watch for if, like I said, with the sweet corn, if the field corn is no longer attractive and we've got peak flights in the area and high trap counts in the area, then you want to be looking in the snap beans. They are really hard to scout for in snap beans. It's hard to find those egg masses. So the last one I'm going to talk about is the fall armyworm. And this is another sporadic pest like the common armyworm. It's very sporadic. It comes in on weather fronts, tends to be a fall thing. Go figure, given the name. July through September, largely based on the storm fronts that we see. It's another fairly nondescript moth, and it's got a single line on its back. So corn earworm has a double line. Corn borer, Western bean cutworm don't have any lines on their back. And then the fall armyworm has that single line on the back. It also has an inverted Y on the head capsule, which is quite characteristic. So if you're seeing that inverted Y leading into one fine single line, then that's your fall armyworm. And they tend to come at the crop with knives and forks. They are voracious feeders. There's nothing subtle about them. If they're in the field, you can easily find that damage. You can find large amounts of frass. They'll even chew like right through the husk to the cob. So it's not an innocuous pest like the corn earworm where you don't even know it's there. You know when fall armyworm is there. They can be trapped for, or just scouting for them is usually more than enough. I don't know of too many people that are trapping for fall armyworm anymore. And then your threshold is going to be about 5 to 10%. So in the next module, I will be covering the foliar disease pests of sweet corn, beans, and peas. If you have any questions at all, or if you're seeing something unusual, or you just want to talk about pest management, then feel free to send me an email or give me a call or a text message. Thank you for joining in on this session today.